So moving on to the next section, let's look and see if they're true or false first of all. Okay, are protons positive? Yep. Are neutrons neutral? Yep. Are electrons negative? Yep. Is the nucleus overall positive? Not necessarily. Okay, so let's cross that one off. Okay, and then based on what we learned in class from our colleagues, okay, this was the video about the plum pudding model.
Negatively charged electrons rotating in concentric rings within a sphere of positive energy.
There you go. Okay, so came up with the negatively charged electrons. Okay, that was the big deal about Thomson. Okay, so let's close that out. Okay, and go back to our question. What did we say? Electrons, negatively charged electrons. Okay, that's what we care about for that question. Moving on. Then we had Rutherford. What did he say? The atom was composed of what? Okay, so that was Dalton, Thomson, Rutherford. So this is before the Bohr model. So the Bohr model has the nucleons, in the nucleus we had the neutrons and the protons, and around that was the electrons. Okay, so before that, what happened before that? Okay, this is where we get our typical from TV model. Okay, so it'll be this one where we look at Rutherford. So we have a nucleus, okay, and we have electrons floating around the outside, but they're not necessarily in any particular orbital. Okay, so which question has to do with that? Let's take a look. So Rutherford, okay, the one that looks like this, okay, is that a large positive nucleus with electrons orbiting it? Okay, it's got protons in it. And is it orbited by neutrons? Nope. So definitely not that one. Okay, now the question is it a large nucleus or a small nucleus? Because it both says positive. Okay, so in this case, you want to try to figure out based on what you've learned before relative to size. Okay, and you're going to go with a large nucleus. Okay, because our electrons are teeny tiny at the top. Okay, and our electrons are big. Okay, so our nucleus is a lot bigger compared to the rest. Okay, next one. The charge on an atom in general, okay, is always going to be neutral. That's a U. And how come? Okay, let's look at the answers. Because there are more protons than neutrons? Nope. Are there more electrons than protons? Nope. Protons and neutrons are equal? Nope. And protons and electrons are equal? Yes. Okay, because protons have a plus charge. Okay, electrons have a negative charge, and we need those to balance out to give a zero charge. Okay, so when we start talking about anions and cations, okay, this is where we don't have equal amounts of electrons and protons. So someone has taken away an electron. So now we have a positively charged ion. Okay, or maybe they have gained an electron. So now they have negatively charged ion. Okay, so it'd be anions and cations. That brings us over to our periodic table. So which of the following describes a metalloid? Okay, again, this one is best done by process of elimination. So metalloids, these are the ones that are in purple on the staircase. Okay, so we know that metals, okay, the green ones, conduct electricity because they're metals. Okay, so these are going to be the metals. Conductive. All right, oh, that one has conductive in it, so that's probably metals. Okay, are they on the left side of the periodic table? No, those are the metals. Okay, so it's not that one. Now let's take a look between metalloid, okay, and the non-metals. What do we have left? Okay, so we know that metals conduct electricity, okay, and non-metals don't, so this is probably non-metals. Okay, so let's compare that with this answer here. Dull, dull, okay, they're both dull, great. Okay, brittle, malleable, not too sure, let's check. Okay, but what's different here? Okay, are they going to be brittle? That means they break easily. Ductile, which means they stretch. Or malleable, which means they bend. So you might want to look at the actual items. Okay, tellurium, astatine, germanium, silicon. Okay, silicon, if you've ever had anything made out of silicone, okay, you know that it's malleable. Okay, so that can help you figure things out. Okay, so that's probably metals, that's probably non-metals. Okay, so this one is the metalloids. Okay, I'm going to stop here just to go to the next page.